Hi students, this is the practice part of fast track revision series of JEE Main. In this video we are going to discuss the questions based on charge, properties of charge, charging and Coulomb's law. Here questions has been picked up in such a way that each and every concept of the topic will be revised. Now let's take the first question. The first question is, a small object is having a charge of 54 into 10 to the power 24 electrons. Consider this as the small object. It is having electrons 54 into 10 to the power 24 and is having a net charge of 3 microcoulomb. And the charge of the object is 3 microcoulomb. And they are asking determine the total amount of positive charge on the object. Then we know the charge on the object means excess charge. And if this excess charge is equal to 3 microcoulomb, then it is equal to total positive charge minus total negative charge. They are asking the total positive charge. Total positive charge they are asking, and total negative charge is given indirectly. Now let's find how to find the total negative charge. They have given the total number of electrons. So total negative charge will become charge of the electron. How many electrons are there? 54 into 20, 10 to the power 24. And charge on one electron is 1.6 into 10 to the power minus 19. So this is the total negative charge. After multiplying it, we will get 16, 4 just 64. 86.4 into 10 to the power 5, or we can say total negative charge is going to be 8.64 into 10 power 6 coulomb. Now, so total positive charge will become from this particular expression. Total positive charge is equal to 3 microcoulomb, 3 into 10 power minus 6 plus total negative charge. Total negative charge is equal to 3 into 10 power minus 6 plus 8.64 into 10 power 6. Now, if you see, this is a very large number as compared to this. This is 10 to the power minus 6, while this particular thing is 10 to the power 6. So we can easily neglect this particular part, total net charge, as compared to total negative charge. So we can say total positive charge is approximately or even almost equal to 8.64 into 10 power 6 coulomb. So here I want to say, what are the concept involved? Charge is excess charge. Total positive charge minus total negative charge is the net charge. Second thing, charge is quantized and it is given by Q equal to plus or minus NE. So these two concepts has been taken and this is going to be your answer. Now take the second question. Now this is also somewhat similar. Total negative charge on the electron is given. We have to find the total negative charge. We have to find total negative charge on 1 mole of helium. And for the helium, they have given the atomic number as well as molar mass. Now we know 1 mole of anything contains how many atoms? Avogadro number. So we have to find the total negative charge of Avogadro number of helium atoms. So 1 mole of helium means we have 6.023 into 10 to the power 23 atoms of helium. And in one atom of helium, there are 2 electrons, atomic number 2. So there are 2 electrons. So total number of electrons in helium atom is equal to Na 6.023 into 10 power 23 and 2 electrons. And what is the charge on 1 electron? 1.6 into 10 power minus 19. So charge on these many electrons will be into 1.6 into 10 power minus 19. So this becomes the circled quantity will becomes the total negative charge. Now when you want to multiply this particular thing, so total negative charge will comes out to be 6.023 into 2 into 1.6. After multiplying it, you will get approximately 1.9 into 10 power 5 coulomb of charge. This will be your total negative charge on 1 mole of helium, right? So answer will be this one. Now take the next one. Now here also concept was similar, means a slight concept from your chemistry that 1 mole of anything contains how many atoms, one atom contains how many electrons or protons, and from there you are using the quantization of charge Q equal to Ne, and then you can find the total negative charge. So these are the concepts involved. So in the properties of charge, if we see the total numerical type questions, then this is the only formula Q equal to plus minus Ne. Now, next will come this question, third question you take. Now, this is the question related to continuous charge distribution. Many students feel difficulty in this type of problem, but I will suggest there's no problem at all. Just have a look how to solve the question. Now, they are saying in the question, a circular ring is there, radius r, one circular ring of radius r, like this which has been drawn, this ring, radius r. It is given the charge density as shown in figure. Means if I take this as the reference line x-axis and I take this as the line where the charge density given here, lambda naught sine theta. As a function of this angle theta, this is the charge density given. We have to find what is the total charge. So let's take, let us take here only, here at an angle theta, you take this angle d theta. Then length of this part will be r d theta, length of this part. Now linear charge density is given as lambda naught sine theta. We know the charge on any small part will be equal to linear charge density into length. So for this small part, what we have taken as the element, this one, for this small part, the charge will be lambda naught sine theta, the charge density at the location of the element, into r d theta. So this is the charge on this particular element, chosen element. So we have to find the total charge. Total charge will be simply the charge on all such elements, that is integral of dq. Now if we do the integral of dq you can write lambda naught r sine theta d theta. Now we have to choose that how the theta will go. Now theta will go from here to here. We have to consider the entire object this way. So if we have to consider the entire object, we have to start from here and we have to go like this way. Then what must be the value of theta? Theta will go from then 0 to 2 pi. 0 to 2 pi. So lambda not common, constant, r constant, integral of sine theta is minus cos theta, 0 to 2 pi. Lambda naught r minus common cos 2 pi 1 minus of cos 0 1. So your answer will become 0, right? So net charge on the ring is going to be equal to 0. Now Why it is 0? Directly also we can say. Now linear charge density is given as lambda naught sine theta. If we see here, if here positive charge, diametrically opposite pair here, it will be equal negative charge. So negative and positive are equal. So here for the similar type of element, so they cancel and the total charge becomes 0 in such a way on these two elements. Same way if we take two elements here, then on this element and this element equal opposite, it becomes 0. If we take one element here and one element here, it will become equal. So the total charge then what will become? It becomes equal to 0 only. So in this way also, without calculating also, this question can be solved directly. So let's move to the next question. This question is previous year JEE main question. In JEE main, this question has been asked. We are going to solve. This is also based on the continuous charge distribution. Now in this question, what is given? Charge is distributed within a sphere of radius r with a volume charge density. Now in the previous question, we were having the linear charge density. But in this question, we are having the volume charge density. So one sphere is there in which volume charge density was given as A upon r square e to the power minus 2r by A. Right? Where capital A and small a are constant. It is given that capital A and small a, they are constant. They are saying if Q is the total charge, what is the radius of this? R. And they are saying Q is the total charge. Then they are asking what is the value of radius R. Means it is slightly different type of question where charge is given and you have to find the radius. In the previous question, they were asking the total charge. Now you see how to solve this. For the spherical distribution, what will be the element we have to take and how we have to proceed. Now let us take, this is our sphere of radius r. Then you take one element which we are taking a hollow sphere of radius r and thickness dr. Means this shaded portion is our small element. Now volume charge density at this location will be given by this expression. At the location of element is given by this expression underlined. Now write what is the volume of the element. Volume of the element, we know it will come out to be 4 pi r square dr. You can easily find if uh, otherwise you can write volume of this particular sphere 4 by 3 pi r plus dr whole cube minus 4 by 3 pi r cube, and then subtract and neglect the higher small terms and you will get this. So what is the charge of this element, this shaded element? The charge of this shaded element will come out to be dq equal to rho dv. Now see, in the previous question we have used dq equal to lambda dl. Here we are using rho dv. So here as a note I am writing the charge on the for the different cases. What you can write? For the linear element lambda dl, for the surface element sigma dA, and for the volume element rho dv. In the previous question we were having the linear element, that's why lambda dl. In this question we are having the volume element, that's why rho dv. Now substitute the value of rho and dv here and get the charge on this element. So you are going to have dq is equal to a upon r square e to the power minus 2r by a into 4 pi r square dr. R square cancelled, 4 pi is common. So we have the charge on this 4 pi a e to the power minus 2r by a dr. This is the charge on this shaded element. Now total charge we have to find. So to find the total charge, we have to go for the integration. So total charge will be equal to integral of dq. Integral of dq means 4 pi a is constant, e to the power minus 2r by a dr. This comes. Now the limit. To choose the limit, you see here. Limit, our sphere is going from here to here, here to here, here to here, here to here. So the limit for r, the value of r goes from 0 to capital R. So the value of r goes from 0 to capital R. So integrate the above expression for 0 to capital R. When you solve it, you will get 4 pi a is common, constant. E to the power x integral is e to the power x only. So minus 2r by a divided by minus 2 by a, because e power minus ax. And then you substitute the limit 0 to r. When you substitute the limit, you are going to get 4 pi a. This 2 I am writing here, and small a upside. This minus sign I am leaving as it is here. This capital R you substitute, e to the power minus 2 capital R by a minus e to the power minus 0, that is 1. So in bracket term we can write minus minus 1 plus minus e to the power minus 2r by a. This comes out to be into 4 pi, that is 2 pi a. This 2 cancel the 4. Now this is coming. So this is equal to the total charge. But what actually in the question they are asking? They are asking the radius. So you have to write it in this way. Q upon 2 pi capital A small a equal to 1 minus e to the power minus 2r by a. Then you can write it as e to the power minus 2r by a is equal to 1 minus q upon 2 pi capital A small a. Take the log on both sides, ln 2r by a with minus sign, or you minus equal to ln, sorry, left side it will become only minus 2r by a. Minus 2r by a is equal to ln 1 minus q upon 2 pi a. Let's see the options. What are the options? Options are 1 minus q upon 2 pi by a upon 2. So R will become this particular thing is coming. Option D. Yes, this is your answer. Then. Now, I will say this is one of the lengthiest questions of the in the JEE main paper. But you see, there if you are feeling that you are not able to solve, I'll suggest strongly these type of question you leave for the second phase. Means in the first phase you solve all easy questions. You take these type of questions later on only. Right? Now let's take the next question. Now three metallic spheres say XYZ have charges 10 Coulomb, minus 10 and 10 Coulomb respectively. X, Y, Z. This is having the 10 Coulomb, minus 10 and 10 Coulomb. Now X, Y, Z are brought in context such that charge of each becomes 3 Coulomb. Now then what is the charge on Z? These three are kept in electrical contact. When they are kept in electrical contact, some transfer of charge will take place. Let us say finally the charge on this given, X given 3, Y given 3, and this is say X. What you have to find? Now, here you don't have to do anything else. Here you have to apply the conservation of charge only. Now, initially before the connection, the charge total charge is 10 on X minus 10 on Y, 10 on Z. And this is equal to final charge 3 on X, 3 on Y, and X on Z. So the value of X comes 4 Coulomb. So the final charge on the Z becomes 4 Coulomb. A very simple question on the basis of the conservation of charge. Now let's take the second one, next one. Now the Coulomb's law questions are starting, and you pay the attention that you see that what are the basic things, so that you won't be able to forget the things. Now, first question, very simple question, but I feel very nice question. If the distance between two equal point charges, sorry, it is not that question which I was talking. Anyway, first we'll solve this. If the distance between two equal point charges is doubled, there are 2 point charges they are saying given, say Q1, Q2. They are saying separation is R. If R becomes double, means 2R, and their individual charges also doubled, means Q1 becomes 2Q1, Q2 becomes 2Q2. Then they are saying what is the new force. Now new force is equal to 1 upon 4 pi epsilon naught new Q1, that is 2Q1, new Q2, that is 2Q2, upon new R, that is 2R. Now this 2 square cancel 2, so it will become 1 upon 4 pi epsilon naught Q1 Q2 by R square. So the charge becomes same, old only. Force becomes the older one only. So if we are separating the separation, we are making double, and we are making also the charges double. Force is not at all changing. So what is happening to the force? Nothing happened. The force remains the same thing. Now the next question we will see. It is given two particles X and Y are 4 meters apart. Two particles are there, they are 4 meters apart. Say the charges of two particles are Q1, Q2. X has a charge of 2Q and Y is having a charge of Q. So charge on X, that is Q1 is equal to 2Q, and on Y, that is Q2 is equal to Q. Ratio of the magnitude of the electrostatic force on X to that on Y. Means they are saying force experienced by 1 due to 2 divided by the force experienced by 2 due to 1. Means what the Q1 charge exerts a force on Q2, that divided by what the force experienced by Q1 due to 2. Now no calculation needed. This is simply a very common statement. Coulomb's law gives the force, electric force, which is an action-reaction pair. So it means if Q1 exerts a force on Q2, F12 or F, then Q2 will exert on Q1 equal and opposite force. So this F12 and F21 are equal. Answer is 1. That is option C. Now, very nice question. Nothing you have to do. You won't take more than 10 seconds to solve this question if you are concentrating. That only required to solve the questions. Now, let us take the next one. Two charged particles Q1 and Q2 are placed at a separation of 2 meters. Now, two charged particles are there, Q1 and Q2, and they are placed at a separation of 2 meters. The charge Q1 experiences an electric force F due to Q2. So here I'll write force experienced by 1 due to 2 is F. Now another charge Q3, one charge Q3 has been brought, placed at a separation of 2 meters from each charge. That is, you can say, now another charge Q3 has been placed so that these two separations are also 2 meters. This is also 2 and this is also 2. Now they are saying In new situation, in this new situation, what is the force experienced by Q1 due to Q2? Now you see what they are asking. Force experienced by Q1 due to Q2. Now again, here nothing to solve, nothing you have to do. Directly you can say answer is A equal to F. Because here they are asking the force experienced by Q1 due to Q2. They are not asking the total force experienced by Q1. And this question can be answered simply in one straight line or without any calculation, that force between 2 point charges is independent of the presence or absence of other charges. Force between Q1 and Q2 is not depending on any other charges. Force between Q1 and Q2 is depending only between those two charge particles. It is independent of any other object present nearby or wherever, right? So let's take the next question. Now, force between 2 point charges Q1 and Q2 placed in vacuum at r centimeter apart is F. When two particles are there, Q1 and Q2, they are placed at r centimeter apart in vacuum. This is F. So F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon r square. Take care of the unit. I have not converted the unit of r. Force between them when placed in a medium having dielectric constant K equal to 5 at r by 5. Now they are saying what is the force between Q1, Q2 when they are at a distance of r by 5 and dielectric constant 5 filled. Now here you see what answer you are going to give. Most of the people will write the force experienced by Q1 due to Q2 in this new situation is 1 upon 4 pi epsilon naught Q1 Q2 upon r square, that is r upon 5 whole square into 5 here K. So it will become 5 times of F. But here the problem, it is a wrong answer. Now if you see, they are asking the force between them. They are not asking what is the resultant force experienced by Q1 or resultant force experienced by Q2. They are asking force experienced by Q1 due to Q2. But what you are getting this is force experienced by Q1. I want to add one word, resultant force. And it is equal to this, say for example, I am representing it by F1. This is equal to the force experienced by Q1 due to Q2 plus the force experienced by Q1 due to medium. In the question, they are asking only this. They are not asking this. This is you have to find. And this will be, F1 value will be the force experienced by Q1 due to Q2 will be 1 upon 4 pi epsilon naught Q1 Q2 upon r square. R square is r by 5 whole square. So this, and this expression is F. So answer will be 25F. And if you see, both the options are there. 5F is also there, 25F is also there. This is the correct answer. Ultimate exclusive concept, and I hope you have understood. Remember this concept. Force between two charges is independent of the presence or absence of other charges. Force experienced, it is a two particle interaction. In short, you can remember this. So these three questions we have taken, and all the three questions are more or less same, but concept is very important. Please remember this. Now one more question we'll take. Now it is the Coulomb's law in vector form. 2 point charges A and B having the charges 1 by 2 Coulomb and 2 Coulomb. So one is A, one is B. This is half Coulomb and this is 2 Coulomb. And their position vectors are also given. This say R1 and this say R2. So it means this is R1 and this is R2. Now they are saying force on the charge at A due to B. Now we have the formula force experienced by 1 due to 2 is equal to 1 upon 4 pi epsilon naught Q1 Q2 divided by R1 minus R2 mod cube into R1 minus R2. Now in vector form, why this question has been taken? Always remember throughout the electrodynamics, if you are using any vector equation involving the charge value has to be substituted with sign. You don't have to bother about the direction. Direction will come out of unknown quantity automatically with sign. You don't automatically it will come, you don't have to bother. Only thing you have to remember, charges you have to substitute with sign. Here there is no problem because both the charges are positive. So you will write 1 upon 4 pi epsilon naught Q1 1 upon 2 Q2 2 mod of R1 minus R2. Let's find the R1 vector minus R2 vector. So this R1 minus R2 vector separately I am writing here. I am writing it as R equal to R1 vector minus R2 vector. So I plus j plus k minus I. So I minus minus I 2I plus j plus 2j plus k minus 3k minus 2k. So this becomes the R vector, means R2 minus R. So mod of this is 4 plus 4 plus 4, 12. So it is 12 under root whole cube. And here you can write 2i plus 2j minus 2k. So after doing this calculation, you will get the answer. This is what is the most important thing, again telling for the vector equations. Charge has to be substituted with sign. Don't make the mistake that you use your brain to find the direction and charge you write without sign. Then it is better to make use of the scalar equation and not the vector equation in such cases. Now take the another question. A certain charge is divided into two parts, Q and capital Q minus Q. Means they are saying one charge is there, Q, which has been divided in two parts, Q, then obvious other charge will be Q minus Q. Now these two charges, Q and Q minus Q, have been placed at some distance, say. Now they are saying, what is the ratio of Q by Q? Find this ratio so that force is maximum. Force experienced by one due to other is maximum. This is what you have to do. Now for this, what you'll do, find out the value of force. So force is equal to 1 upon 4 pi epsilon naught Q into Q minus Q upon R square. Now it is obvious force is depending upon the small q. Now you have to find the value of F so that small q value of small q so that the capital F is maximum. So use maxima minima df by dq. For maxima or minima, df by dq is 0. This 1 upon 4 pi epsilon naught r square is common. And here you write capital Q is constant. So Q into capital Q is Q only minus Q square, that is 2Q. For maximum or minimum, this will be 0. After keeping it 0, you will get Q equal to Q by 2. To check whether it is maximum or minimum, you can find the second order derivative, and second order derivative, when you find, you are clearly visible, it is going to be negative. Negative second order derivative means at q equal to capital Q by 2, F is maximum. So we are getting the, as per the question, what is the maximum. So in that particular case, what is the ratio of Q by Q? For F to be maximum, 1 by 2. So it means your answer is this. It means to if you want to divide the capital Q into two parts so that the force between those two parts is maximum, you have to divide them in equal parts. So this you can write as a note also. You can add in your notes, and this will help you a lot in solving some question. Like you take the next question. This is the previous year JEE Main question. The question what we discussed just now, this one is not previous year JEE Main. This is a very common question actually, this 11th one. But this 12th and 13th what I am writing, they are the previous year JEE Main question. Now 12th question. Now they are asking a charge of 4 microcoulomb is to be divided into two parts. Charge of 4 microcoulomb has to be divided into two parts. Say Q1 and another will be 4 minus Q1. The distance between the two charges is constant, means R is constant. The magnitude of the divided charges so that the force between them is maximum, means what is the value of Q1 and this so that force is maximum. Just now we have seen there has to be divided equally. Answer will be 2 and 2. Right? Next question you take. A 10 microcoulomb charge is divided into two parts and placed at 1 centimeter distance so that the repulsive force between them is maximum. Now again the same concept, 10 microcoulomb charge divided into two parts so that the force between them maximum. What are the charges of the two parts? 5 microcoulomb and 5 microcoulomb. Right? So this way. That's all for now. Remaining questions of Coulomb's law we'll discuss in the part 2. Okay.